Okay, let's start the TikTok live. Oh, but not teaching. Okay, no problem. Maybe you also love math lah, so you just want to watch. Okay, so come. The very first thing that you all learn about differentiation is the 5 rules. Okay, 5 rules. Okay, let's talk about the name first lah. Let's talk about the 5 rules first. So the 5 rules. Okay, so let's talk about rule 1 first. Rule 1. Okay, so let's say I want to differentiate 3x squared. This one easy lah. Okay, if I want to differentiate 3x squared, don't ask me why, but this is a method. Got student, why must bring down? Why must bring down the power? I also don't know why, but this is a method. This is the how they differentiate. Okay, so bring down the power. So 2 multiplied with the 3. So you will look at 2 multiplied with the 3x, then the power you must minus 1. So it become 1. So in the end you get 6x. Okay, this is actually rule 1. Actually rule 2 is a bit lame lah. My student was asking me, what's the difference between rule 1 and rule 2? Because it's like, that's why usually when I teach my student, I teach rule 1, rule 2 is together one. Then the rule 3 is the chain rule. Then the rule 4 is the product rule. Rule 5 will be the quotient rule. So rule 2 simply means that if I have 2 terms or more terms, let's say for example I have 3x squared plus 5x cubed. There are 2 terms here, right? When we write dy dx, or when we write dy dx and when we write d dx, can. Okay, I'm going to explain this part. Give me a moment first. After I explain rule 2, I clarify on the part. That is a common thing that students always have. Common problem that students always have. So actually rule 2 simply means that when you have many terms, you just differentiate each of them as per whatever rule you need. Let's say this is the first term. Okay, differentiate 3x squared is actually applying rule 1. Okay, no, I don't do IGCSE additional maths, only O level. Okay, so I will differentiate this as per rule 1. So I bring it down, so 6x. Then after that, for the second term, I will differentiate this as per whatever rule that I need to apply. For this case, we're going to apply rule 1 under the second term. So it's bring down the 3, 5 times 3, so it's 15, power minus 1, so it's 2. So actually rule 2 simply telling you that when you have many terms, you differentiate individually as per whatever rule you need. That's all. That's why it's called rule 1, rule 2, that's all. So rule 1, rule 2 is something like a bit of it's like a bit not very clear on their boundary lah, but it's actually linked. It just simply means many terms, you just differentiate them separately. Okay, so now student asks, when do you use dy dx, and then when do you use d dx? Okay, when okay, so dy dx is if your expression, okay, if your expression is given a name, that means like maybe y. Okay, let's say I say y is equals to 3x squared plus 5x. You see here, I give a name to my expression. So my y is equals to 3x squared plus 5x. So we want to differentiate our y, so I'm going to differentiate y with respect to x. So when you differentiate y, dy dx equal, you're trying to say that you want to differentiate the y, which is this, with respect to x, and then straight away just differentiate, you get 6x plus 5. Oh, sorry, wait, let me see whether I can. Okay, give me a moment. Okay, so no problem. Do remind me if my screen go haywire, because I'm looking at 3 screen. So when I teach. Sometimes I cannot see the screen. So super, you all have to highlight to me if you all cannot see. So you see, you give a name to your expression. So my y is equals to 3x squared plus 5x. So therefore you will say, okay, I'm going to differentiate y, which is this expression, and with respect to x equals to 6x plus 5. Okay, so you see, not necessary that it must be y lah. Let's say for example today, if I say, okay, I want to let g equals to 3x squared plus 5x. Okay, we are not wrong, we are not wrong. It's just that we're giving it a name only, so it's not necessary that it must be y, correct or not? So if I say g equals to 3x squared plus 5x, now I want to differentiate this expression with respect to x. I say dg dx, agree or not? And then I get 6x plus 5. No, it's always dy dx. I never say that can use dx dy, did I? I didn't say that, I did not say that, It's always dy dx. You can never use dx dy, It's totally different meaning, You want to differentiate y with respect to x. So your dx definitely is at the denominator. Okay? So I'm trying to say g is the name of the expression. With respect to x is because your g is in terms of x. So technically speaking, even if today I say my g is equals to 3a squared plus 5a. Okay, I want to say, okay, I want to differentiate my g with respect to a. It also, okay, 6a plus 5. Right? So it is just the language of differentiation. Okay, so now the next thing is, how about the d dx? How about the d dx? D dx is like, for example, the question, let's say they just tell you, they say, okay, differentiate, let's say, x cubed plus 3x squared. The question says differentiate this. Okay, they say differentiate this only. They never give a name to the expression. So this expression is nameless, no nothing, no name, right? So in this case, let's say you don't, either you say let y equals to x cubed plus 3x squared. Then you will say, okay, I'm going to differentiate y with respect to x. So after I differentiate, I get 3x squared plus 6x. That's one way. Okay, that's one way. Another way is, okay, I don't want to name my expression. I don't want to name. I just want to straight away differentiate. So I will say, okay, now I want to differentiate with respect to x, whatever is inside this expression, this bracket. So we have x cubed plus 3x squared. So you see here, I differentiate with respect to x, whatever is in this bracket. Because I never give a name to my expression, Then after you write the equal, it must be after the differentiation. Okay, so it will be 3x squared plus 6x. I don't even know this person. Why do I have to wish your friend happy birthday? I think you too boring, too bored, Okay, so kids, this is what it means, So why is there d square y dx square? That is differentiate, higher derivative. That means you're going to differentiate one more time. You're going to differentiate one more time. You see, dy dx. Let's talk about this part, This is a differentiate one time. Yes, I'm doing product rule after this. Let me explain about the dy dx versus d dx first, So dy dx means I differentiate from the y one time. So if d square y dx square, that one is chain rule. Okay, step by step, we haven't reached there yet, So you see, I want to differentiate one more time. So it will be d square y dx square. That means I want to differentiate my dy dx with respect to x one more time. So based on the 6x plus 5, when I differentiate, I get 6. Can I use dx dy if x is some y expression? Yes, you can, but you don't see that lah. You don't see that. I mean, technically speaking, if your expression is x in terms of y, yes, the language you should write is I want to differentiate x with respect to y. Then it is correct. Okay, so now I'm going to move on. Differentiating second derivative is just second derivative, and the use of second derivative is used in the nature of points at when you are doing application of differentiation, the stationary point. You want to find the nature, we use second derivative to find. Okay, I don't do H2 math. Okay, so now after rule 1, rule 2, we will have rule 3. Today I'm just doing 5 rules. Please refrain from asking me anything which is beyond the 5 rules, because you are disrupting my planned lesson today. Okay, so rule 3. Rule 3 is chain rule. Okay, chain rule. Okay, chain rule. Thanks for the gift. Okay, so chain rule. So what is chain rule? Say for example, I want to differentiate even those like okay, 3x squared plus 5x squared. Okay, I'm going to put cube. Then to the power of 2. Actually should not be 2, maybe 3 lah. Because to the power of 2, usually I don't use chain rule. To the power of 2, I can just expand and then apply rule 1, rule 2. Okay, cube. I don't. Of course, technically speaking, I can still expand now. But the thing is, I don't want to spend time expanding it. Understand? So I can just apply chain rule to differentiate. So if I want to differentiate this, I will bring down the power. This one you copy. Power minus 1, just like what you do for rule 1. Then you multiply by differentiate the inside. Then when you differentiate the inside, then you see what rules you need to apply. So, differentiate the inside, actually I apply rule 1 on the first term, apply rule 1 on the second term. So, it will be 6x plus 15x squared. So, in the end, this one I still can take a common factor, 3x. So, this one becomes 9x, 3x squared plus 5x cubed to the power of 3. This one, because I take out 3, so I left with a 2x, 5. I take out x already, so it's just 2. Plus, take out 3 already, so 5x. And we are done. So this is chain rule. Okay, rule 3, chain rule. Okay, let's talk about the product rule and the quotient rule. I'm going to just talk very generally how the product rule and quotient rule. Okay, yes, must factorize. You need to simplify. Okay, later part when we are doing the questions for learning, you will see better how we do for the individual, especially the chain rule, product rule, and quotient rule. So the rule 4 is the product rule. Okay, so example, I want to differentiate x plus 3 to the power of 6. And then 2x minus 5 to the power of 4, example. Okay, let's say I want to differentiate this. There's no way we can go and expand this and expand this. Yes, I can apply binomial theorem to expand this, binomial theorem to expand this, and then after that multiply them together, but I think that will take ages lah. So in this case, we will apply is something x expression multiply an x expression, and both of them you cannot both of them are x. So in this case, you will apply product rule. So product rule is, for me, for my way of doing it, is I'm going to keep the left hand side. And I'm going to differentiate the right hand side. Okay, plus I'm going to keep the right hand side, and I'm going to differentiate the left hand side. So in other words, product rule is keep left differentiate right plus keep right differentiate left. So that is the product rule. Okay, so then after that, see, let me continue. X plus 3, 6. So when I differentiate this, see, when I differentiate this is applying chain rule. Applying chain rule. So bring it down. So it will be 4, 2x minus 5, power minus 1, which is 3. Remember to multiply by inside because you are applying chain rule inside here. So differentiate inside is a 2. Plus, this one keep no change. Differentiate the right. Differentiate the right. It will be bring down the 6. X plus 3, power minus 1, 5. Multiply by differentiate inside. In this case, differentiate inside, although it's a 1, so just put a 1 here. Okay. Okay, so in this case, after doing this, many students don't know how to simplify. Okay, so you need to know that this is one term and this is the second term. Okay. Okay, so now these two terms, we're going to take out the common factor. Why is it 2? This one is because we differentiate the inside. Remember just now when we apply the chain rule, when we do the chain rule over here, when you differentiate this, you bring down the power 3, this one copy, power minus 1, which is 2, multiply by differentiate the inside. You need to differentiate the inside, and then you put it outside here. So over here, I'm applying chain rule on this one. So I bring down the 4, copy, power minus 1, that's why it's 3, multiply by differentiate the inside. And when I differentiate the 2x minus 5, it is a 2. Plus, keep this, differentiate this, I again apply the chain rule. Chocolate cream puff, if you are seriously learning, I will be very happy, but can you don't complex the whole situation? The thing that you are asking is, I think you are trying to be funny, okay, so bring down the 6, copy, power minus 1, multiply by differentiate inside. When you differentiate inside, it is a 1, but make it a habit to put, even if it's a 1, just put a times 1. Okay, make it a habit so that you know that, oh, I remember to differentiate the inside and put it outside. Okay, so now let's simplify. I need to take out the common factor. So let's take a look at this one. In terms of number, 4 times 2, I have 8. 6 times 1, I have 6. So 8 and 6, the common factor is 2. So that means I can take out a 2. As for the bracket, okay, I take out the common factor 2, and then after that you have 2x minus 5 to the power of 4. This is O level. So I'm going to take out 2x minus 5. Sorry, very distracted by the chocolate cream puff. Okay, anyway, this 2x minus 5 to the power of 3 and to the power of 4. Take out the smaller one, so I will take out the 3. The x plus 3 and x plus 3. Which one is smaller? We will take out the 5. So you will take out x plus 3 to the power of 5. Put a very big square bracket. Okay, thanks Nick for helping me to speak up. Let's just ignore him so that you all can learn. Nick, you also need to focus. Thanks for helping me to answer the chocolate cream puff. Okay, anyway, see, I take out all this common factor already. So now, this first term, when I 8, I take out 2, I still left with a 4. x plus 3, 6. I take out x plus 3, 5, right? So I still left with x plus 3, 1. And of course, 2x minus 5, 3. I take out this. I don't have already. And I just left with a 1. So now, let's take a look at the second term here. So this second term, from the number 6, I take out 2. So I still left with a 3. As for the bracket, 2x minus 5, 4. I take out 3. So I still left with a 2x minus 5. This one, I take out exactly everything already. So no more. So that's how I simplify. Chocolate cream puff. If you haven't even learned this topic, then what are you asking in this channel? Can you please refrain yourself from texting? I'm going to ask my moderator to block you. And when you block me, that means you can never see my content anymore. If you're not learning this topic, don't try to join in and talk about all these things, can? Because you are disrupting other people from learning. Okay, so now simplify this whatever is in the square bracket. So you have 2x minus 5 cubed, x plus 3, 5. This one no change. I just need to simplify here. Rainbow, 4x plus 12 plus 6x minus 15. 2x minus 5 cubed, x plus 3, 5. 4x plus 6x, 10x minus 3, close. And that's how you simplify. Okay? Wait, give me a moment. Okay, so you need to know that other than knowing the rules, how to differentiate using product rule, you must know how to differentiate as a simplify. Okay, you need to know how to simplify. Yes, the simplifying is the one that is tough. Okay, so you need to know that after you apply this part, so you see from here to here, what you need to know is you got to see these two as this as two terms, because this is something times something times something times something, so this is considered a one term. Okay, and then after that, this you will have to know that, okay, from this term I need to take out the common factor. Common factor, always take out the smaller one. Can show the square root one. Later I have questions on that one. I'm not going to show here. Later then I show the square root one. And my questions inside. See here? I have one question today prepared already. Okay? Give me a moment. I'm going to do something. I already get my moderator to block him. I think sooner or later he will disappear. Okay, come. Rule 5. Rule 5. So rule 5 is quotient rule. Okay, quotient rule. Let's say for example, I want to differentiate x plus 3. Okay, I will only talk about the simplified version. Okay, I just want to generally talk about these 5 rules. Later we will have practice question. Rabbit frog. Exactly, that's exactly how I'm feeling. Okay, because the question that he asked is practically you will just roll eyes until don't know where already. Okay, so x plus 3 and 2x minus 5, for example. Okay, I want to differentiate this. So, how do you know whether do you use quotient rule or you can actually use other rules? Would it be easier to set the first and second term into u and v? Actually, I don't. Yes, this life is only about differentiation. 5 rules only. Okay, I don't like to use the u and v lah, so troublesome. But of course, some student, some school I know the school teach like let u be this one, then you do your du dx. Then let v be this one, then you do dv dx. And then after that, you go and combine them together. But I feel that it's not necessary lah. It's a bit waste of time. Okay. But of course, if you are comfortable doing that way, please go ahead. Yes, I'm focusing on this 5 rule differentiation because it's very critical, very important. If your 5 rules differentiation are not strong, you don't have to talk about, you don't have to even learn normal tangent, rate of change, or whatsoever application of differentiation because your basic is already not there. So if you cannot differentiate properly using the 5 rules, it's difficult for you to do the behind part. Yes, okay. Can I just use one rule? No. Unfortunately, you need to know all 5 rules. You cannot just learn one rule. It's not like saying option. It's all 3 is compulsory. It has to depend on what is your why. Then you got to decide which rules that you need to use. So, quotient rule is for me, 保上位下 then 保下位上 when quotient 保上 no, it's 保下 first. Eldon fan, it should be the other way around. The bottom is more important, so 应该是保下才位上。These people very funny one. People are learning here then all these people just come in and disturb. They really 吃饱没有事情做。Okay, come. So over here, okay. Yes, I have just texted my moderator to block yellow as well. Let's continue the work. Let me drink a sip of water. And then after that, let's go back to learning quotient rule. Okay, so quotient rule is keep the bottom. So I always tell my student, bottom is more important. Keep the bottom first. So you keep the bottom, differentiate the top. In this case, the top is just 1 minus, and be careful, quotient rule here is have to be minus. Okay, then after that, now you have to keep the top and differentiate the bottom. In this case, it's a 2, and don't forget to put over bottom square. I have students who differentiate, they only left with the numerator, the denominator disappear. The bio link is not working. Really? What happened to today? The feng shui today is not very good, is it? Why everything like all crashing down, is it? No leh, my bio link is working. I'm not so sure why you say your bio link is not working. I just use my another account to check. It's all working fine. Okay, so now what you need to do is just simplify the top. So this one is the easy one, the general. Today I still have I have prepared actually. Let me see how many questions. I have 6 questions for us to practice later. Okay, So later we will try. So over here, simplify, I will just have 2x minus 5 minus x and minus 6 over 2x minus 5 square. So it's equals to x minus 11 over 2x minus 5 square. So basically the 5 rules are these. In generally, these are the 5 rules, okay? In generally, okay. So now we're going to do the practice question, Okay, I already spent 40 minutes talking about the 5 rules. We haven't even started doing any question yet. So just now some student asked, how about those square root 1, blah, blah, blah. Okay, you will see in this worksheet, minus 2x. What thing minus 2x? How come the x doesn't get multiplied? Okay, I know someone spot the mistake. Sorry, my bad. I was rushing through the quotient rule. So that's correct. These two, because I want to multiply with this one, so it's minus 2x. This one is minus 2x, then minus 6. So in the end, it is just minus 11. Okay, thanks for spotting the mistake. Okay, come. Let's do the question number 1. This thing. Yes, we're going to use product rule. Okay, so it is given that y equals to x squared multiplied by square root of this one. This one, you know that there's no way we can rainbow the square root one. So in this case, we know that it's something x multiplied by something x. I know what you mean. I don't encourage. I know what you mean. So, some students like quotient rule, like example, just now that question, right? Where is it? Oh, sorry, behind. This one. Okay, some student ask, okay, can I change it to bring up, like it become d dx 2x plus 3 and then say 2x minus 5 to the power of negative 1. Okay, so the student is asking whether can change to this one and then after applying product rule. It's still workable, but I cannot remember which question, but I know there are times whereby when you change it to this form, it's very difficult to differentiate. The quotient rule is easier. So when it's not advisable. So to me, I feel that it's not advisable. Got fraction, you use quotient rule. But be careful, A, B, C, D, E, F. When it is a fraction, not necessary that it's quotient rule. Because you have to make sure that the numerator has x, the denominator also has x, then yes, you use the quotient rule. But a lot of times, okay, let's say for example, d dx, like this morning my student, let's say 9 over 2x minus 5. Example this lah. Okay. Then, to differentiate this, she go and use a quotient rule. So I tell her that don't have to. Okay, I tell her that don't have to use quotient rule. This one, because my numerator has no x, so we should change this to chain rule. This one, we can actually change it. Okay, you see, if I'm changing it, the expression is not differentiating, so it will be 2x minus 5 to the power of negative 1. So actually what we do is, we're going to change it to this form and apply chain rule, that's all. Then I just need to bring down the minus 1 times 9, I get minus 9. 2x minus 5, then power minus 1 become minus 2. Differentiate the inside, it is a 2. And then because the power is negative 2, I just need to, okay, so it's minus 18 over 2x minus 5 to the power of 2. Right, so be careful is not say, oh, see fraction, that means straight away is quotient rule. This one, numerator is actually a number, there's no x. So I actually can bring up the 2x minus 5 up, and then it become a chain rule, just using chain rule to differentiate. Right? Okay, let's move on. Change back to positive power. Don't keep in negative power. Today I cannot OT. Today I'm going for my atas dinner. For those who know, I did mention it. I think my previous live I got talk about it. Yes. So today I got a dinner, so I cannot OT. So let's see how many questions we can do. Okay, I need to adjust. Pretty annoyed by the setting of the screen. So difficult to. Okay, so come. Now I'm going to change this. Y is equals to x squared bracket 3x minus 2 square root is to the power of half. Change it to this form first so that it's easier for you to differentiate. So for this situation, we will have to use product rule, because an expression x squared multiplied by another expression in terms of x. So we're going to use product rule. Okay, so dy dx, keep left, differentiate the right, and when my right hand side I have to apply chain rule. So bring down the power 3x minus 2 minus half, multiply by differentiate the inside, which is a 3. Plus, keep right, which is 3x minus 2 to the power of half. Differentiate the left hand side. This one is I am applying the rule 1. Okay, so it will be 2x. So now, this is the time whereby I need to take out the common factor, right? So just now the question that I demo, the power is positive and then its whole is integer. Now you see I have fraction and somewhere you have negative. Then how do you do? Okay, so same thing, same concept. This is considered one term, this is considered one term. So let's analyze. Okay, now I have a very questions to ask you first. So let's say with the logic. Let's say for example x cubed minus x squared. When we want to factorize, we look at x cubed and x squared. We take out the smaller one, correct? So you take out x squared, and then whatever you left is you take 3 minus 2, so you left with a x. X squared minus x squared, so you left with a 1. Agree? So this is our normal algebra factorization, taking out common factor. So it's actually the same concept. Okay, so now let's take a look. Let's take a look at the number first. So we have half times 3, and then x squared, and then here got 2x. So actually I can take out an x. I can take out x first. Okay, take out x. Okay, now the bracket. See here. You see, we always take out the smaller one. Agree or not? Here is 3x minus 2 minus half. This is 3x minus 2 half. So of course we want to take the smaller one. Negative half is smaller than half, so we're going to take out negative half. Okay, so take note. Take out the negative half. So we will take out 3x minus 2 to the power of negative half. Put a very big square bracket. My first term, I took out x and the 3x minus 2 to the power of negative half. So I will left with 3 over 2x. So I will left with 3 over 2x. And then of course this one when I take out is 1. I don't have to write. Okay, now let's take a look at the second term. The half, when I take out negative half, I left with what? You see, let's back to the fundamental. Back to the fundamental. X cubed, when I take out x squared, I will take 3 big number minus small number, so that I know that I left with a 1 inside. Agree? So in this situation also the same thing. I will take the big number minus the small number, . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . and it become 1. Okay, so you will take note. You will notice that after you do a lot of product rule and quotient rule, you realize that actually every time after we take out, we left with 1 only. You don't left with 1, that means somewhere is wrong. So half minus half, actually we left with 1. So we left with 3x minus 2 to the power of 1. I'm not forgetting there's still a 2. Because I only took out x, so there's still a 2. So I have to put a 2 in front and close it. Okay, so now let's further simplify. So this one remain the same first. I'm not going to touch it. So let's simplify inside. So I have 3 over 2x plus 6x minus 4. Okay, I'm going to make the inside bracket here, because there's a 3 over 2, right? I'm going to make this into a single fraction. But before I make into a single fraction, let's simplify this one first. 3 over 2x plus 6x, they are like terms. How do I get 3 over 2? Half times 3 is 3 over 2. Okay. So we have x, 3x minus 2 minus half. This one, 3 over 2 plus 6. So I get 15 over 2. So I left with 15 over 2x minus 4 over 1. So I want to change this into a single fraction. I get 15x times 2 times 2. So this is minus 8 over 2. Okay, so now it's easier for me to simplify into a single fraction already. See, so single fraction. So the x belongs to the top. Be careful. This minus half only belongs to the 3x minus 2. Okay, so if you're going to bring up to the denominator as the positive half, you only bring down this one. Don't touch the x. The x supposed to be at the top. Okay. You have to wait until end of the lesson, then I tell about next slide. Next slide, I think, is binomial. Okay. So my x remain at the top. Then my 15x minus 8, of course, remain at the top. This one, the 2 is here. This to the power of minus half, I'm going to bring it down. And when I bring it down, I don't write to the power of half already. I write the square root. So it will be square root, actually just 3x minus 2 is fine. 3x minus 2. And we are done. See, exactly the same. No, not exactly the same. They rainbow the x in, so just do one more step. Because we need to show exactly the same. So we just say, okay, 15x squared minus 8x over 2 square root 3x minus 2 shown. Of course, as fast as possible. I'm taking a long time because I'm explaining. It's not tough actually. Actually, the concept, as long as your algebra is strong, actually all this concept is about there one. It's just that it seems like it's very tough. So firstly, you all need to know the fundamental reason of like factorizing out. Okay. Only this time now you need to deal with negative fraction. That's one thing. 6 minutes a bit too long. I don't think this one takes 6 minutes. I think this one 2-3 minutes actually can be done. Okay. So now wait. I want to say what? Then next thing is you must know how to deal with fraction. So just now a student asked, if I suddenly got 3 over 2x, correct? Yes. So you need to know half times 3 is 3 over 2. And when I put 3 over 2x, you need to know that the x in the middle belongs to the top. Okay? Okay? Then, next thing is, when you have a fraction here, what do you do? So, you need to know the combine to a single fraction. So what I did is I combined into a single fraction, make them into the same denominator. Okay, all these you all learned in Sec 2 algebra already, correct? So actually it's just all combined together. Okay? So that's how you do question number 1. Oh, I want to cry already. Almost 6 o'clock and I'm still at question number 1. Okay, let's move on. Okay, question number 2. Actually, this lesson start 5 to 6 lah, but today I super OT already. Okay, let's just quickly do maybe 2 more questions, then I have to end the live because I got dinner tonight. Then I will just upload the balanced solution. No, it's not every day. I have my full-time job as a full-time tutor. I got my own students who teach. I only teach on TikTok live for free only twice a week. 2 hours. Every Wednesday 8 p.m. to 9 p.m. and every Sunday 5 p.m. to 6 p.m. Okay, so now this one is a quotient rule. So now I want to differentiate 2x over square root x plus 1. Okay, see here. So this one you will have to use quotient rule. Okay, look at the numerator has x. Denominator also have x. So we're going to apply quotient rule. So we need to keep the bottom. Okay, keep the bottom. Just now we have mentioned that we are supposed to keep the bottom. So keep the bottom, but I'm going to keep bottom. I'm going to put it in terms of the to the power of half. Okay, so I will say, okay, I keep the bottom. So you're got to be very clear. This is keeping the bottom. So it is not doing any differentiation. So it must be exactly the same. So my bottom is square root, so it's to the power of half. Keep the bottom, differentiate the top, which is a 2. And we are supposed to subtract. Keep the top, which is 2x. Differentiate the bottom. You see, because the bottom, if I don't write in the to the power of half, it's difficult for me to visualize that I want to apply chain rule. That's why I put it in this form. And reason also is because in case I need to take out the common factor to the power of half, this is so-called the index form, it's easier for us to see what common factor we can take out. So now we're going to differentiate the bottom, so it's bring down the power, so it will be half, copy, power minus 1, so it's minus half, and differentiate inside is 1 over bottom square. Okay, so we are done with the quotient rule, right? Next is we need to simplify. Now you look at the numerator. You have x plus 1 to the power of half, x plus 1 to the power of minus half. So you actually have to apply the same concept as what we did just now by looking at this as 2 separate terms and take out the common factor. So half and minus half. So for those who have learned just now, can you tell me, should I take out half, the bracket half, or should I take out the half bracket negative half? Should I take out the bracket with the half or the bracket with the negative half? Which one should I take out? Yes. Okay, good. Take out the negative half because it's smaller. Well done. So we shall take out x plus 1 to the power of negative half. Put the very big square bracket. You see, this one is my first term. So half minus minus half, I will left with 1. But don't forget there's still a 2 here. So I left with a 2 with x plus 1 to the power of 1. I don't have to write the 1. Okay, so now then let's take a look at this part. So now this one half times 2x is actually x. So I still left with a minus x minus half, when I take it out, no more already. So actually this one I only left with a minus x. Close it. So now see here, this one is x plus 1 to the power of negative half. Remember, we need to bring it down because I don't want my power to be negative. So but take a look at my denominator. I already have a 1 at the denominator. When I bring this down, I have to do 1 plus half. So my denominator now become 3. Now my denominator will have x plus 1 to the power of 3 over 2. Let's simplify here. This is 2x plus 2 minus x. So we have x plus 2 over, don't leave your answer in this fraction form. So denominator is 2, so it is actually a square root. Then we have a 3 here, this is a cube. So this is how you get the answer shown. Okay? Okay, so that is how you do this quotient rule. Okay, let's move on to the next question. Okay, so I want to differentiate my y with respect to x. So this one we want to use product rule. Okay, but before that I need to change this to x plus 3, 2x minus 3 half. Just now we did a similar question, so hopefully now you will be able to do it together with me. So we keep the left, differentiate the right, apply chain rule. Power minus 1, so it's minus half. Don't forget to multiply with differentiate the inside, which is a 2. This is product rule, so this is a plus. Now keep right, 2x minus 3 half, differentiate the left, which is 1. Okay, for product rule, you want to keep left, differentiate right, or keep right, differentiate left first. It doesn't matter because the middle is a plus, so it doesn't matter. But for quotient rule, it's very important that you have to keep the bottom first. Okay, so again, I hope today you already learned the skill of taking out the common factor. So this is my one term, this is my second term. So as for number, let me see, number. Oh, I forgot to write my no, correct. Okay, so take out the common factor. Half times 2 is 1, so actually there's no number that I can take out. So I only need to take out this one, 2x minus 3 to the power of negative half. So 2x minus 3, wait, very ugly. So 2x minus 3 to the power of negative half. So this first term, I will left with half times 2 is 1, nothing, so I only left with x plus 3. This one, half minus half, so it's 1. So I left with a 2x minus 3 to the power of 1. Close it. So then simplify whatever is inside the square bracket. So we have x plus 2x, which is 3x. 3 minus 3, which disappear. Then next, you bring down the negative index to the denominator. So this becomes 3x over square root 2x minus 3. And we're done. And whenever they put it into this form, right, like they ask us to put into this form, I will say, okay, I compare, then I see, oh, then I will say where k equals to 3. And we're done. Okay? So that is for question number 3. Okay, now let's move on to question number 4. Okay, if you notice, actually it's all the same, similar. Let me see whether there's anything slightly different or not. Actually, it's all the same. Yeah, it's all the same. I already teach you the tough one, which is the taking out common factor. As long as you understand the concept of taking out the common factor, dealing with the negative fraction, and then everything else is fine. It's the similar, same one. Okay, let's just do this question. Okay. So I'm going to change this to x multiplied by 4x plus 1 to the power of half. So let's do our dy dx. I hope by now you're already expert, huh? Question 3. I think my team will upload to the Telegram channel, you can actually grab the solution from the Telegram channel. I hope you're in my Telegram channel. Okay. Okay, so differentiate this. X multiplied by something. So again, it is two x expression multiplying each other. So we're going to apply product rule. So keep left, differentiate right. Power minus 1, so it's minus half. Differentiate the inside, which is a 4. Keep right. Differentiate left, which is a 1. So again, these two terms, we're going to take out the common factor. Okay, this is half times 4, so it's 2x, but here got no number, so I'm going to just take out the bracket. So take out 4x plus 1 to the power of minus half. So I left with a 2x. This one I left with 4x plus 1 to the power of 1. Close it, and we are done. So you see, it's all similar, So I have 6x plus 1. I got a shock. Okay, yeah. Over, bring this down, square root 4x plus 1. Again, when you compare, you will say, oh, where my c is equals to 6 and my d is equals to 1. And we are done. Okay, next we're going to do a quotient rule with square root kind. But okay lah, not that tough, same concept. Okay. Once you are able to master the product rule and quotient rule, okay, and understand the underlying foundation behind product rule and quotient rule, then your differentiation will be smoother lah, smoother. Okay, so we're going to apply quotient rule. So let's see. Now I'm going to keep the bottom, and remember I said when we want to keep the bottom, we put it in the index form. So I'm going to write 2x minus 3 to the power of half. Keep the bottom, differentiate the top. Minus, keep the top, differentiate the bottom. Then look at this form so that it's easier for you to differentiate. You're applying the chain rule. So it will be half 2x minus 3 minus half multiplied by differentiate inside, which is a 2. And don't forget to over your bottom square. Over the bottom square. So square root 2x minus 3 square. Okay, if you are fast enough, you don't have to write this. You can straight away just write 2x minus 3 because you know square root after you square is just the inside. Yeah. So again, apply, repeat the same thing again. Taking out the common factor. So I'm going to take out the 2x minus 3 to the power of negative half. So 2x minus 3 to the power of negative half. Half minus minus half, so I left with 2x minus 3 to the power of 1. Okay, this one have to be careful because you got minus and then this one got bracket. So half times 2, 1, I take out this one, so I only left with x minus 1. And my denominator is left with a 2x minus 3, 1. Now let's simplify the square bracket. 2x minus x, so I left with x. Minus 3 minus minus 1. Minus means plus 1. So I have minus 3 plus 1, so it's minus 2. Now my denominator, 1 plus half, so it's 3 over 2. So it will be square root 2x minus 3 to the power of 3. And we are done. Ta-da! Exactly the same. So say it is shown because they ask you to show. Why did you factorize 2x 3 negative half? Okay, I've already just now earlier on I have already mentioned and teach why is it that we take out negative half. We always take out the smaller power. You see the half and negative half, you take out the smaller power, so we take out the minus half. It's the same concept like if x cubed, I want to take out x cubed and x squared, I want to take out the common factor, we take out the smaller one, which is x squared. Right? So this one, although it is fraction, but it is still that, I still want to take out the smaller one. So negative half is smaller than half. That's why we take out negative half. Okay? So then after that, why is it that this is 1? Is because, let's say x cubed, you take out x squared, you take 3 minus 2, correct? So, same, when I take out negative half, I take half big number minus a small number. Half minus negative half become half plus half. So that's why I left with a 1. Okay? Yes. Okay, once you understand this concept, then you understand. Okay, so that's for question number 5. Ooh, actually still okay lah. Because once I teach about the taking out common factor, it's actually pretty fast. Okay, now let's move on to the last question for the day. Okay? Again, it is similar. You see, actually all these questions are from other school past year paper. You can see that they are always asking the same thing over and over again, just changing it a little bit here and there. Okay? Okay, so I will say, okay, y is equals to 3x squared plus 2 to the power of half. So let's differentiate this Okay, so since this is the last question, come, you all tell me what should I write. How? What should I write? You all stay here now. Nobody learning already Means I can off work already lah. Okay, keep left. After that, what should I write? Don't worry, you try, never know. If you are wrong, then just learn from the mistake. Come, the J, you tell me 3x only. Don't tell me your dy dx is only 3x. Oh, no sound. Okay, I'm going to just proceed because again, like I say, I'm rushing for dinner. Okay, come, keep left, differentiate the right hand side. The right hand side, actually we're just going to apply the chain rule. Half 3x plus 2 no leh, A, B, C, D, E, I never see your answer leh. I never see what you type. I only see the Hong Zhong type. Okay, so Hong Zhong, I assume that your power got minus half. Okay, so bring down the half. 3x squared plus 2 power minus 1, so it's minus half, multiply by differentiate inside, which is 6x. Plus, now keep the right hand side and differentiate the left, which is 3. Oh, really? Okay, never mind. A, B, C, D, E. Maybe later after we ending, then he suddenly pop up the answer. Maybe lagging lah, maybe lagging. So I've already differentiate. So now let's take out the common factor. Okay, so take note that before I analyze taking out which bracket, which is actually taking out the bracket is easy, is the number that we have to decide what we need to take out. So I have 3x. I have 3x times half multiplied by 6x. Over here I have 9x squared. Agree now? Half times 6x is 3x. 3x times 3x is 9x squared. Agree? So 9x squared and versus 3 means that I can actually take out common factor 3. So we can take out 3. Not to worry that what if student ask me, what if I never take out about the number, I only just purely take out the bracket. Actually also can. It's just that when ending part, you need to know that your bracket has is more complex. Then you need to simplify more complex. But eventually you still need to take out the common factor one. Understand? So why don't we just straight away take out the common factor? Sometimes even after you take out the common factor at the first stage, at the last step, the bracket, you still have to take out common factor. Later part you will see. Okay, later part in this question, it has the same issue. So 9x squared, when I take out 3, so wait, sorry, okay, so take out the 3 as well as 3x squared plus 2 to the power of minus half. Put a very big square bracket. So 9x squared, when I take out 3, I stay with a 3x squared. This one minus half, take out minus half, no more, as in not no more is 1. This one, half minus half, I left with a 1. 3 take out 3, no more, so I left with 3x squared plus 2. Okay, so 3x squared plus 2 minus half, so I have 6x squared plus 2. Look at this last bracket over here. Then you realize, 6x squared plus 2, I still can take out common factor 2 So actually you can still take out 2. So take out 2. So the 2 will multiply with the 3 here, so it becomes 6. So 3x squared plus 2 minus half. This one take out 2 already, so I left with 3x squared plus 1. Then simplify it, it becomes, take note, remember the 6 cannot go down. The 6 must be at the numerator. Okay, I want to highlight this. So 6 bracket 3x squared plus 1 over square root 3x squared plus 2. You can keep your answer in this form, but because this question said they want it in the form of ax squared plus b, so then you need to rainbow in the 6. So now it becomes 18x squared plus 6 over square root 3x squared plus 2. And you will tell them that, okay, my a is equals to 18 and my b is equals to 6. And we are done.